Today we're diving deep into the constellation Carina. Now this isn't just any collection of stars. It's a grand, dramatic fragment of the legendary ship Argo, which was once the single largest constellation in our entire sky. Tucked away deep in the Milky Way, Carina is a stage for cosmic extremes. It's home to both a guiding beacon for our furthest space missions and, at the same time, one of the most volatile, explosive objects we've ever discovered.
So, here's our flight plan for this exploration. We'll start with Carina's mythic past as part of the great ship Argo Navis. Then, we'll get our bearings, figuring out where and how you can see it in the night sky. We'll uncover how this giant constellation was broken apart, and then zoom in on its two most incredible superstars. After that, we'll tour its most stunning deep sky objects, before finally connecting its ancient story to our modern adventures in space.
All right, let's start by rewinding the clock. On the star charts of ancient astronomers, you wouldn't find a constellation named Carina. Instead, you'd see it as the keel, the very backbone of a colossal celestial ship known as Argo Navis, the vessel of the legendary Argonauts.
Now, this really gets to the heart of Carina's identity. It's a fragment. It sits in a dense, star-rich part of the Milky Way, and its entire history is one of being a piece of something much larger. It's a shard of an ancient celestial legend that astronomers later had to break up just to make their maps manageable.
Okay, let's shift gears from history to practical stargazing. To really get to know Carina, we need to understand its vital statistics. How big is it, and where on Earth do you need to be to actually see it?
Carina covers 494.2 square degrees of the celestial sphere. To put that in perspective, that ranks it as the 34th largest out of the 88 modern constellations. And within that area, under ideal viewing conditions, about 206 stars are visible to the naked eye, making it a pretty rich field for observation.
Carina is without a doubt a star of the southern hemisphere. Whether or not you can see it depends entirely on your latitude. If you're anywhere south of 15 degrees north, so basically the tropics and everything below, you get a perfect, unobstructed view of the entire constellation.
Now, for observers in the band between 15 and 37 degrees north, you'll only be able to see the northern parts of Carina. Crucially, this does include its brightest star, Canopus. But the further north you go within this zone, the closer Canopus will appear to hug the southern horizon.
And if you happen to live north of 37 degrees latitude, well, you're out of luck. Carina will always be hidden below your horizon. It's a spectacle reserved for the southern half of the world. And if you go far enough south, past the 37th parallel, its brightest star, Canopus, actually becomes circumpolar, meaning it circles the celestial pole and never sets.
So why was this giant constellation broken up? Well, back in Ptolemy's time when he was charting the heavens, Argo Navis was just too big to be useful. With over 800 individual stars, it was an absolute nightmare for astronomers trying to accurately name and map everything inside it.
The pivotal work here was done by the French astronomer Nicolas-Louis de Lacaille. During his expedition to the Cape of Good Hope in the mid-18th century, he undertook the monumental task of systematically mapping the southern sky. Recognizing just how impractical Argo Navis was, he made the decision to formally divide it.
Lacaille broke the ship into three new constellations: Carina, the keel; Puppis, the stern; and Vela, the sails. And here's a neat historical artifact. He kept the original Greek lettering system, the Bayer designations. That's why Carina has an alpha and a beta star, but the next letters in the sequence, gamma and delta, are actually over in the constellation Vela. It's like a breadcrumb trail leading back to their shared past.
Now we're going to focus our analysis on the two most significant stellar objects within Carina. They represent a study in stark contrast. One, a stable, shining guidepost. The other, a volatile and cataclysmic giant on the verge of self-destruction.
Let's start with Canopus, the second brightest star we can see. Its intense brightness and its location far from the ecliptic, the plane of our solar system, make it an ideal cosmic lighthouse. In fact, NASA uses it as a reference star to keep interplanetary probes like Voyager and Pioneer correctly oriented on their journeys into the void.
To give you a sense of scale, our Sun is a pretty standard star. Canopus, on the other hand, is a supergiant. It is about 15,000 times more luminous than our Sun and 70 times larger in diameter. It is an absolute monster.
From the stability of Canopus, we now pivot to the chaos of Eta Carina. This object defies easy classification and represents one of the most extreme astrophysical environments known in our galaxy. The object we call Eta Carinae isn't a single star, but a binary system of two massive stars. Their combined luminosity is staggering, 5 million times that of our Sun. This immense energy output fuels extreme instability.
Back in 1843, this system underwent a cataclysmic event known as the Great Eruption. It briefly became the second brightest star in the sky, ejecting several solar masses of material into space. Today, it's considered a prime candidate to go supernova, and perhaps even hypernova, in the near future.
The direct visual result of that eruption is the Homunculus Nebula. It's a bipolar emission nebula with a distinct hourglass shape. The two lobes are expanding clouds of gas and dust thrown out by the star during that 19th century outburst, a visible scar from a near-death event.
But Carina is more than just two stars. Because it lies right in the heart of the Milky Way, it is absolutely packed with other incredible sights. Things like nebulae, star clusters, and unique patterns of stars called asterisms.
The star of the show here is the Carina Nebula itself, a glowing cloud of gas 4 times larger than the famous Orion Nebula. You can also spot the Southern Pleiades, a beautiful star cluster, and watch out for 2 cross-shaped patterns. One is the Diamond Cross. The other is the infamous False Cross, which fooled countless sailors in the past. They'd mistake it for the true Southern Cross, which they used to navigate and sail completely off course.
And this brings us right back where we started, linking the ancient myths that gave these stars their names to our own modern voyages into space.
The myth tells of the voyage of Jason and the Argonauts to retrieve the Golden Fleece. Their ship, the Argo, wasn't just any vessel. The goddess Athena herself had embedded a piece of a sacred, prophetic oak into its keel, the very part of the ship our constellation is named for. This keel could speak, guiding and warning the heroes.
This creates such a powerful parallel. The ancient Argonauts, led by Jason, used a prophetic keel to navigate treacherous waters on their quest. Today, the new Argonauts, our robotic probes, are sent by humanity on a quest into deep space. Their ship is the probe itself, and their unerring guide is the steady light of Canopus, the brightest star in the celestial keel.
So, where does that leave us? Science may have dismantled the ancient myth of Argo, but it's replaced it with a story that's even more astonishing. We are still explorers, sailing into the unknown, guided by the very same stars our ancestors wove into legend. And that makes you wonder, as we travel further into space, what new myths and what new legends will we create?